In Chapter 3, we are going to study logic. One of the reasons why we study logic is to help improve upon our reasoning skills, such as deductive reasoning. It can also help us to evaluate the validity of a claim or a statement. And better yet, it can also help us to present a more convincing statement or a better understanding claim, or even an equivalent claim or statement. So we will start with 3.1, talking about statements. Let's take a look at the screen here, and we can see that there are a few different types of statements or comments or questions. It says, I'm so hungry, get me some food. Can I have something to eat? In this chapter and section, you're going to learn how to decipher statements, how to manipulate the statements such that they are either equal or equivalent statements, and understanding the truth values of these statements. Definition of a statement. A statement is a sentence that is either true or false, but not both simultaneously. So in other words, when you make a statement, it has what's called a truth value. It's either true or it's false. And here are two examples of statements listed for you. The first one is, London is the capital of England. Number 2, William Shakespeare wrote the television series Modern Family. Now, we're not here to debate whether or not these are true or false. We're just merely stating that this is a statement. In symbolic logic, we use lowercase letters such as P, Q, R, S, T, U, V, letters of the alphabet, to represent statements. Here are two examples. Statement P is, London is the capital of England. Statement Q is, William Shakespeare wrote television series Modern Family. So rather than working with the entire sentence, we can just use the letters that are assigned to it, the lowercase letters P or Q. The next paragraph reads, the negation of a statement P is expressed by writing not P. So if I have P is, London is the capital of England, the negation is not P. And it has a tilde in front of that lowercase p, also read as not P. And the way you would say the statement now is, it is not true that London is the capital of England. And I'll write that out for us. It is not true that London is the capital of England. So this is the negation of the original statement. Remember, the original statement is P, the negation is not P. And you can see how we inserted that word not. And easier yet, to represent not P, we can just insert the word not. London is not the capital of England. I believe that way it's a little bit easier to understand that all we're doing is inserting the word not for that tilde, the negation. Here's an exercise to help review what we know about statements. Recall that statements are either true or false. They are not questions and they are not commands. So let's look at the first one. New York City has more people than Atlanta. Is the given sentence a statement? And since it is not a question, it is not a command, and we can attach a truth value of it's either true or false to it, we say yes, this is a statement. The next one states, wait a minute. Wait a minute. Is the given sentence a statement? In this case, this is a command. So therefore, it is not a statement. All right, so this says the negation of a true statement is a false statement. So if the original statement is true, the negation would be false, and vice versa. If the negation of a false statement is going to be true. So if the original statement is false, then the negation would be true. Form the negation of each statement. So let's take a look at the first one, A. It says Shakespeare wrote the television series Modern Family, and we need to write the negation of this. So let me start us out with just saying Shakespeare. And since it said he wrote, we're going to say Shakespeare did not write. And we'll rewrite the rest of the sentence. Did not write the television series Modern Family. All right, then we'll take a look at the second sentence, and it says, today is not Monday. I'm looking at B right there. So the negation of that statement would be, today is Monday. So when you write the negation, we're either going to add on the word not or to make it negated, or we're going to remove the word not to change the truth value of that statement. Form the negation of the statement. And this statement says Thursday does not come before Friday. So the negation would be for us to eliminate and make sure we remove that word not. So looking at A, B, C, and D, we would say Thursday comes before Friday. And my answer would be D. All right, and the next problem that we have says, let R represent the following statement. One thinks hard, and that is a statement. One thinks hard. Express the statement, one does not think hard symbolically. All right, so we're going to express that statement symbolically. And one does not think hard. It includes the does not. So this turns into tilde R, the negation. Remember, the original statement is R, one thinks hard. And then this new statement they provided for us is actually the negation of R. This table demonstrates negations of quantified statements. So the original statement for the first one is stating all A are B. All A are B. So if you think about your Venn diagrams, you would have a little circle A inside a larger circle B for set B. The negation for this is some A are not B. Some A are not B. So if we stop right there, we can see that if you have the word all, I'm at the bottom now, if you have the word all and you want the negation, you rewrite the sentence using some are not. All right, so think of all converts into some are not. And if you started with some are not, you can actually turn that around and change it to all. Let me see if I can fix my little arrows over here so you can see where I'm at. All right. Again, so if we start out with the original statement as all, we're going to change it to some are not to make it negated. And they have some examples here. All people take exams honestly. So I'm right here. Put this big circle. Then we're going to go look at the negation, and it says some people do not. So some do not take exams honestly. So you can see that that is the negation. And then let's take a look at the next statement. It says some A are B. To write the negation, you say no A are B. So once again, if you have your original statement with the word some, we're going to change that over to no. Or if your original statement starts with no A or B, the negation would be back over to some A or B. That's why we have these little arrows right here, that double arrows, to show you that you can go back and forth on these, but these are negations of one another. Example for this one is some roads are open. So they started with the word some. The negation says no roads are open. So we went from some to no, and if we started with no, we would convert it to some. So these mini Venn diagrams should help us to visualize these statements. We'll take a look at this first one, and it says all poets are writers. And you can see the writers circle, or the set, is enclosed or encapsulated inside the poets circle. So it means all writers are poets. Now, if you remember what we just went through, we did all. If we start out with all, it changes to some are not. I'll just put a little comma here so you can see that some not. All right, so if you want to say that together really fast, you'll say awesome not. All right, awesome not. So the negation over here says some writers are not poets. And now you can see that these two circles are intersecting, and this part over here on the right-hand side represents the writers that are not poets. So some writers are not poets, and that considers to be the negation for the original statement. All right, let's take a look at the second example. It says some canaries weigh 50 pounds. And so they're describing this area of intersection where some canaries weigh 50 pounds. The negation for that, remember when it says some, just the word some, the negation of that is to change it to no. So when you separate the two circles, as in the negation part of it, you get no canary weighs 50 pounds. No canaries weigh 50 pounds. So it would be a good idea to add this little description onto your notes or formula sheet, because this is probably the area that will help you rewrite your statements into negations. Notice that we have two separate sets, one labeled college students and the other one business majors. This is asking us to choose the correct statement below that illustrates the relationship between the two sets. So let's look at A first. A says all college students are business majors. So when that happens, you should have a circle embedded inside another circle, because it's saying all college students are business majors. So the college students would be the interior circle, business majors would be the outside. And that Venn diagram does not match the one they provided for us. So this one is not an option. Then part B says no college students are business majors. No college students are business majors. So this one actually matches. I'll put a little dot right there to make sure there's not more than one correct answer. This one matches our Venn diagram. C says some college students are business majors. So in this case, you would have two circles that intersect, and it says some college students are business majors, and that would be the intersection region represented on that. And again, that is not two separate circles, so C would not work. Same thing with this. This says some college students are not business majors, so you would have two separate circles that are intersecting. And let's say the first one is my college students. I'll put S for students, and this is for M for my business majors. Some college students are not business majors. That would be this region right here. So you can see again, it is not two separate circles. So B is definitely the correct answer. So if it helps you, draw out a Venn diagram that describes each of the statements, and you'll see which one supports the original Venn diagram that was provided. All right, so this says some grapes are green. Which of the following expresses the quantified statement in an equivalent way? So we want it to be an equivalent way. So for safety issues, let's do that Venn diagram. Some grapes are green. So I will put this to represent my grapes. And then I will have my other intersecting circle, which will represent green. And it says some grapes are green. So that is representing this region in between where they are overlapping it. Some grapes are green, but not all the grapes are green. All right. So let's take a look at the answers. We want one that has the equivalent shaded region, two circles intersecting. And let's take a look. It says not all grapes are green. So in this case, for statement A, you can have two separate circles. Again, I'm going to keep the grapes on the left side, the green on the right side. Not all grapes are green. So that one actually would shade this region here. Not all grapes are green. So that doesn't look like my original one. B says there are no grapes that are not green. There are no grapes. So now here's my grape circle here that are not green. So that's what that one looks like. Green is the outside circle. The grapes are the interior shaded circle. So all of it would be shaded because they represent all the grapes. C is no grapes are not green. No grapes are not green. So once again, you're having the same thing. Here's my grapes. No grapes are not green. That means they're all green. And lastly, it says at least one grape is green. So if I have two separate circles here, I can say right here, this is my one little grape and it's green. And since it falls inside the interior area, we can say that it matches the original statement, or at least one grape is green. So my answer for this one would be D. At least one grape is green. Now you do not always have to draw a Venn diagram to help you out, but this is just another tool that you can use to help you get through these statements. Let's look at part B. Part B says, which of the following statement is the negation of the quantified statement? All right, so when you think of negation of statements, you want to remember what we just finished going over. All, if there's a statement that has just the word all, we would rewrite it for the negation to state some are not. All, some, not. If we start with a statement that has some, we can write the negation by changing it to no, and vice versa. So in this case here, our original statement says some grapes are green, way at the top. Some grapes are green. So we're starting here with the word some, and we're going to translate it into the word no. So the one that has no grapes are green is A. And that would be my final answer. For our last slide here, we have nobody doesn't like a day off. Nobody doesn't like a day off. Express the statement in an equivalent way. So let's just read through all of these. A says no people like a day off. Some people do not like a day off. All people like a day off, and some people like a day off. This one says nobody doesn't like a day off. So to make an equivalent way of saying this, we would say all people like a day off. So if you wanted to do this as a Venn diagram, you would say this is the circle that represents day off, and nobody doesn't like a day off. So this is my people, and that means that everybody enjoys a day off, which would match option C. All right, then let's take a look at B. It says write the negation of the quantified statement. So if we don't know how to change nobody doesn't like a day off into a negation, what you can use is the equivalent statement that we just found, where it says all. Remember, once again, all, the negation converts into some not. So we'll take a look at all the options below. It says all people like a day off. B says some people like a day off. C is some people do not like a day off. And D says no people like a day off. So what I'm looking for is some not, because we started with the word all. In this case here, some do not. So my answer for this one would be C. So it takes a little bit of practice, but make sure you practice on writing it in an equivalent way so that you can convert it into a negation.